We are going to review how to use simplify radicand. So what does that actually mean? If I give you root of 2, this is simplified radicand. If I give you, for example, square root of 8, I would like you to try to rewrite the same, to give me the square root of 8 written with smaller numbers. So I will show you how that's done. So it's very useful to have a table. I will give you that table on the side with all the perfect squares, with squares and cubes of the numbers. So, for example, my number 1, 2, 3, 4, 5, 6. Let's go up to 6 right now. So the square of that number is 1, 4, 9, 16, 25, 36. I'll stop right here now to show you first how we simplify when we are working with the square root. So let's say I have square root of 8. I want to rewrite this number 8 as a product of one of the numbers that is a perfect square and something else. So I can obviously rewrite square root of 8 as the square root of 4 times 2. Now when I have a perfect square under the root, I can divide this is square root 4 times square root 2. Now I'm going to calculate what is the square root of 4, that's 2, and square root of 2 I keep. Now I have the simplified expression. My square root 8 is same thing as 2 square root 2. I'm using smaller numbers. It's easier to operate with this. You will see it later. This is basically learning how to rewrite a number that it's going to be easier for you to operate. So let's look at the second example. For example, I give you square root of 32. Is this a perfect square? Can you, if you take the root of 32, do you have a clean number? No, 32 is not 36, it's not 25, so you need to try to simplify it. Again, look at the table. Can you rewrite 32 as one of these numbers multiplied by something? So if you are not sure, and it's not always going to be obvious, you can try dividing. Can you go 32 divided by 1? Fine. 32 divided by 4? Yes. You can do it 4 by 8, but try to go as far as you can. So I can use 16, obviously. So 16 times 2. You will do the same thing as the first example. Rewrite this as square root 16 times square root 2, which is equal to 4 square root 2. So square root of 32, I can rewrite as 4 square root 2's. So basically, the idea is to look at the table with your square values and to rewrite the root. I will give you one more example. Let's say square root of 75. Try to divide 75 by 36. I cannot divide by 25. I can. So that's 25 times 3. Again, the same thing, 25 times square root of 3. This is equal to 5 square root 3. That's the first part, when you have only digits. Now, if I give you a variable also under the root, for example, I will give you, first I will just show you the variable. Let's say I have x cubed. Look at what kind of the root you have. This is the square root. If there is nothing here, it means that's a square root. So what I always do is I'm looking at how many times I have 2 in 3. Or if you want, you can rewrite it like this. X squared times x. So this is x cubed. But now again, I can divide this root in square root of x squared and square root of x. Square root of x squared is just x, and this is square root of x. I simplified. I have less exponents on my variable under the root. It's going to be easier to operate. Or the other way that you can do this is if I have square root of 3, you can apply the rule of writing the rational exponents and radicals. Okay, here is the rule on the side. You can rewrite this as x 3 over 2, which is equal to x 1 and 1/2, or x to the 1 and x to the 1/2. So this is equal to x square root of x.